First, I'm going to start out by talking about wind direction and what affects it. So what does affect wind direction? As you can see on our first slide, pressure gradient affects wind direction. This is where wind goes from high to low pressure. High pressure has more air molecules and gets to be very crowded, meaning air molecules want a place to go that is less crowded. The greater the difference in air pressure, the stronger the winds, which gives us our strong Oklahoma winds. Next is the Coriolis effect. It is caused by the rotation of the Earth. Wind moves in a straight line, but since the Earth is always rotating, this reflects the straight line, turning it into a curved line, causing this to affect the wind direction. Friction also affects wind direction, but is only present close to the ground. Friction impacts and reduces the Coriolis force. Near the surface, wind direction won't be parallel to the isobars. It always acts opposite direction, which slows down the wind. Now we will talk about wind direction in high and low pressure systems. In high pressure, the wind looks to be moving clockwise and the arrows are moving away from the center. This is considered diverging. Whereas in the low pressure system, the wind moves counterclockwise and the arrows are moving towards the center. This is converging. The direction of these arrows are due to the Coriolis force. The picture on the right shows wind blowing inward in low pressure zones and outward in high pressure zones. Because of this, we get bad weather in low pressure zones and we see our nice weather during our high pressure zones. Low pressure zones are cyclones, whereas high pressure zones are anticyclones. Why does the low pressure zone give us our bad weather? Because the wind converges and pushes the air all upward, and we know that when air is forced up, this creates our clouds that produces our bad weather. However, during high pressure systems, the air is diverging, meaning no bad weather is being created. Now we know the Coriolis effect combined with convergence explains general circulation of Earth's air. When air combines with one another, we have convergence near Earth's surface, causing air to rise, and when it moves away, it sinks. Near the equator, we have rising air pressure zones known as the equatorial low. The upper air rises and sinks back towards the surface. Where this air sinks is called the subtropic high. At the surface, air moves towards the equator or poles. Air that moves towards the poles is known as the westerlies, and the air moving toward the equator is the trade winds.